Welcome to this whirlwind tour of the Suborbital Extension Engine SE2. Allow me to introduce Proxies, an example application we have created to help showcase the power of WebAssembly-based extensibility. This imaginary company provides its customers various networking services, such as load balancing, caching, as well as protecting its customers' servers from security breaches and network attacks. It also presents a dashboard to its customers where they can see all traffic to their servers in real time. Let us put ourselves in the shoes of Ada, a Proxies customer who just noticed something suspicious after logging into her service dashboard. Proxies is a generic service provider to thousands of customers, therefore we can't expect them to notice, but Ada doesn't have any WordPress installations. These requests to the WordPress admin page are clearly malicious in nature, with bots targeting a large number of servers, not just Ada's. Normally there wouldn't be much Ada could do about this, since perhaps sending a report to customer service. But Proxies has recently announced a new feature that allows all of its users to customize how their traffic is handled using the Suborbital Extension Engine. Now let's see this in action. Extensions can be written in pretty much any programming language that can target WebAssembly. For now, I'll just go with JavaScript from the list of languages enabled by the Proxies team. And with a click of a button, I can open up a code editor right here inside the dashboard. Here, we are presented with a minimal JavaScript example to get us started. But to speed things along, I'll just use an extension I have already prepared for this demo. The extension's code is a couple lines of largely idiomatic JavaScript. Fundamentally, extensions will receive some input, they process that input, and may return some output. In SE2, extensions are compiled to WebAssembly and are executed in a strict sandbox. Which is just to say, any other interaction with the outside world would have to go through SE2's Configurable Capabilities API. Capabilities may give extensions access to network requests, database connections, and various other things, which are then exposed as module imports in the JavaScript SDK. In this extension, I'm only using the log API to have it log any unexpected issues with the input data. Now that we have the code in the editor, pressing the Build button is all it takes to get a deployable WebAssembly module built by SE2 from the source code, saving me the hassle of installing language tooling or ever needing to open a terminal window. Once the build is done, I can use the sample input here to quickly test that the extension does what I expect. Requests to the offending WordPress login page should report the suspicious activity back to Proxies. Proxies integration expects modules to return a list of tags. Using Proxies documentation for the extensions feature, I made sure that our module responds with a correct tag, reporting the suspicious activity and allowing Proxies to tailor their abuse detection and mitigation service. The time has now come for us to deploy our new extension and return to the dashboard. Proxies has picked up on a new deployment and has started executing the extension for every request, passing it metadata on the inbound connection. As we can see, requests marked suspicious by a module are now highlighted in Ada's dashboard. Behind the scenes, Proxies may even use aggregate data from its various users to further improve its ability to shape and filter incoming traffic. So how did Proxies arrive at this architecture? The engineers set out looking for an extensibility solution with a few requirements in mind. It had to be high performance, flexible, secure, and easy to integrate with. SE2 happens to tick each of those boxes. With WebAssembly at its core, SE2 provides extensions with an unparalleled combination of security and performance. WebAssembly modules from all customers written in diverse languages get executed in a densely packed, efficient data plane, carefully isolated from the core of the system and one another. Registration for the hosted version of SE2 only takes a minute and comes with everything you need. The provisioned environment grants access to a full-fledged API with wrapper SDKs available for JavaScript and Go, as well as the embedded editor, the WASM module builder, the high-performance data plane, making it a breeze to integrate SE2 into any application. Last but not least, integrators may also choose to host SE2 in their own Kubernetes cluster, particularly useful for users with strict latency or data locality requirements. Hope you have enjoyed this little tour. If you would like to learn more about SE2, be sure to check out our website at suborbital.dev.